Now I'm going to show you how to make measurements to calculate our friction coefficients, the static friction coefficient and the kinetic friction coefficient. So here's my equipment. I have a surface, a clipboard that I'm using. I have a object that is a calculator with no rubber feet. It's just smooth plastic, slides easily. And I have a ruler for measuring distances. So what we're going to do is we're going to take the calculator and you can see on the surface, if I tilt it to a particular angle, eventually the calculator is going to slide off. So we want to make angle measurements of where this happens. So what I'm going to do is I'm going to put the surface at a shallow angle, put the object on top of it so that it does not slip down. And what we're going to do now is lift up the surface until the calculator begins to slip. So this is when the static friction coefficient is being overcome, when static friction is being overcome. Right now, this is being held in place by static friction. So if we lift this up, it looks like at about 15 centimeters is where is the height at which the calculator slid. And the other dimension in this direction is about 28 or 29 centimeters. So I have a right triangle, one side 15 centimeters, one side 29 centimeters. All right, so that's our static friction coefficient. For our kinetic friction coefficient, we are going to make a slightly different measurement. The kinetic friction coefficient is going to be at a lower angle, and that's going to be the point where the calculator, once it starts moving, it continues down the ramp. So you'll see here, if I slide the calculator, it is just barely sliding down the ramp. If I make the ramp a little less steep, if I try to slide the calculator a little less steep, if I try to slide the calculator, it stops. So even when it is moving, the kinetic friction is enough to stop the object. So if we raise it up a little higher, kinetic friction is still winning. Kinetic friction still, oh, this is really close. So somewhere just above this, so this is 8 centimeters. So somewhere there between 8 and 9 centimeters, with the other direction being about 29 or 30 centimeters. So that's how to make our measurements of the geometry. And with these numbers, we can calculate our two friction coefficients for this combination of surfaces.